Good day. Welcome to the Solid Experts Technical Tip Series. My name is John Nolan. I'm a technical representative in the New Hampshire office for Solid Experts. Today I'm going to show you using some of the additional free functionality in SOLIDWORKS to troubleshoot a costing issue with a sheet metal part. The part design is all done, it's complete. I have a good sheet metal feature. I've even used the gauge table in this case with a bend radii and the entire bit. So that's okay. But when I send this part out for quote, I get an estimate back for my cost much higher than I expected. Now the question is why? If you have the Pro and Premium, you can run costing for sheet metal and that'll give you a good idea. But if you don't know your labor rates and so forth, you're not a production house, you just want to have some guidelines. There is a tool, and it's in your Express products. It's called DFMxpress. Now the first time you use it, it will kick you up a request for code, and you go to mysolidworks.com and get your code, and that'll be good for the entire time you run that particular version. Once you have your code and you're running it, now I go here to my settings button, and I want to make sure I'm on sheet metal. The first time you use DFMxpress, it may be in fact defaulted to mill and drill. So make sure we're on sheet metal. Down here, some of the default values can be quite large. So this last one is the bend radius, and I'm going to change this to 1.5. Remember my sheet stock was 1.2, and I usually want a minimum bend radius, at least my sheet thickness or a little bit bigger. Now, when I come back to that and run, it actually does a bit of an abbreviated feature recognition. And it gives me a quick point up. Here it's highlighted where my bend radius is minimal or below my suggested rule. And sure enough, when I highlight those are the bend radii associated with this hem feature. And sure enough, if I look at that hem feature, I've got a flat or closed profile hem, which, yes, absolutely, that's a much smaller radius than my preferred rule. Here I'll switch it to a rolled hem, make that my 1.5 rule radii, and rebuild. Now you may not be able to live with that case in every scenario, but in this case, if I go back, rerun my DFMxpress, now all my rules are cleared, even the bend radii. So this is just an illustration of how to take the DFMxpress tool, apply it to a sheet metal part, run your rules, and get an idea of what perhaps is driving up your purchased part expense. And it'll give you a clue as to what features you may want to edit to adjust for that expense. How do you develop sheet metal rules? You can find them on the web if you do a search for some of your design guidelines. Certainly go to your vendor if they offer it and on their website. Also, the Society for Manufacturing Engineers has several good textbooks on the basic sheet metal forming technologies, press brakes, air bending, and so forth. This has been your Solid Experts technical tip for August. Thank you for your time and attention. Good day.